Okay, is the audio better? Sorry, there was a small glitch with the audio. So is the audio coming through now? Yeah, I just fixed the audio. Is the audio coming through now? Can you please confirm? Okay, now it's audible. Okay. So somebody is asking, what are we going to cover? We're going to take up 3 to 4 problems and variations of these problems, and we'll discuss how to solve them in an actual interview setup. These are problems that you can typically encounter in programming rounds of interviews of companies, whether they're good startups or product-based companies. Again, these are programming rounds for specifically machine learning and data science roles. Okay, I hope that is clear. So, okay, so somebody, so Rahul asks a question that he's able to understand the videos, but he's struggling a little with assignments. Rahul, don't worry. That's a very common thing. We intentionally have assignments slightly on the harder side in general, but we want you to put in your effort because there is no deadline per se. It's not that you have to finish an assignment in 1 day or 2 days. Take more time, but solve it step by step based on the guidelines we have given, based on references we have given. It is a process of solving the problem step by step that will help you learn what is required for a machine learning job. So that's very common. Don't worry on it. Please keep going ahead. Anywhere you're stuck, feel free to email us. We'll give you hints. We'll give you more references. We'll give you pointers, all of that stuff. Of course, we do not give solutions, but we'll give you all the help needed to complete the assignment successfully. Okay. So don't worry about that. Cool. So Nishant says, I've joined the course a month before. Okay, this is my first live session. Nishant, if you have covered some of the basic programming concepts, again, there might be some programming questions here about slightly advanced topics, but some of the questions will be very basic programming, recursion, inbuilt data structures in Python, etc. So again, most of the problems we cover here are typically problems you encounter at product-based companies or top startups. Right, the programming rounds for machine learning and AI for those types of companies. Okay. Sarib, we are not covering dynamic programming questions here because again, dynamic programming questions are very popular for software development engineer roles or people who come from computer science background. They are not often asked for machine learning and AI roles. For machine learning and AI roles, it's mostly about mathematical thinking. It's about using basic concepts of programming, basic inbuilt data structures. That's what we'll cover in today's session. Cool. Cool. One second. Okay, so here is a question. This is a question from Tanmay about revision. Again, we'll get started with the live session itself in a minute or so. So remember that revision is something that you do constantly and consistently. We often recommend, again, at the very beginning of our course videos also, we talk about something called Feynman's technique. And we also talk about intervalled revision. So any concept you learn, have 1 day in a week to revise all the concepts that you have learned. And all the concepts that you learn in a month, also revise it maybe for a couple of days at the end of the month. Constant revision is important, especially this because it is a new topic that you're learning, right? So please remember that that's very important. Again, I'm seeing some requests for other live sessions. We have them lined up. We will do these live sessions as we have, I think some of you have emailed us also these suggestions. We will surely do those live sessions, but we're trying to prioritize in the last few weeks, mostly focusing on interview questions because they will help you get into companies, right? Sounds good. So let's get going here. Let's start with this whole session. Okay. So let me give you the context of today's session so that you know where we stand. Again, I will not be able to answer all the questions in the chat window now because it's already 7:01. Let's get started with today's session. Okay. If time permits, if you have time, we will surely answer. I'll surely cater some time to some general Q&A at the end of the session. Okay, cool. So first and foremost, this session is an interactive interview question session where we'll cover typically programming questions that are very popular for ML, AI and data science roles. These need not be the programming questions for software engineer roles. Okay. So for software engineer roles, there is more focus on data structures algorithms. For ML and AI, there is more focus on foundational coding, basic concepts, basic inbuilt data structures, and especially mathematical thinking. Because if you want to join a company as a data scientist or a machine learning engineer, you're expected to have strong mathematical foundations. Some of those mathematical foundations are also tested, and also the conceptual understanding of some ML concepts can also be tested through programming, as we'll see some examples. Okay, cool. Okay, so let's get going here. So, okay, so just to give you some context here, in most companies, you will have 1 or 2 programming rounds. Again, the type of programming round will differ based on the role itself, right? So basically, if you're interviewing for a data scientist role, right? If you're interviewing for a data scientist role, typically you will have basic coding where you're expected to know, where you're expected to write basic loops, right? Recursion for sure. You're expected to know basic inbuilt data structures. Especially if you're a non-CS student, you're expected to know lists, hash table or dictionary, sets, the basic data structures that come with a programming language like Python. You're also expected to be good in SQL, and you're expected to know basic algorithms like divide and conquer, which is nothing but what we do in recursion, right? And of course, in a lot of this coding, you're expected to handle all the boundary cases gracefully. Simple stuff. It's not going to be very, very hard in any way in terms of data structures and algorithms, right? So very basic stuff. I'll show you some code. Now, if you interview for a machine learning engineer role, typically for machine learning engineer role, people who interview are people who have software engineering background or machine learning engineer background. So again, the difference between data scientists and machine learning engineers is typically in most companies is machine learning engineers also write production code. So handling boundary cases is given very, very important priority when you're interviewing for a machine learning engineer role. And again, there is more focus on writing more optimal code, better time complexity, better space complexity, using the appropriate data structures to solve problems. Similarly, there is a third type of role that companies sometimes ask, which is called as an applied scientist or a machine learning scientist role. For these roles, there is going to be more focus, even in programming rounds, on math, right? So in most of these rounds, typically you will have 2 questions, typically, but there might be instances where you could have 3 questions. There could be instances where you have only 1 question in an interview, but this 1 question will get unwrapped, which means you might be asked some version 1 of a question. You go tackle the question, then the interviewer can go deeper and give you complex variations of this single question, right? So in each of these again, there could be some specific, especially for data scientist roles, there are some companies which have a dedicated SQL round itself. Again, we have done a live session earlier, I think a month ago or so, where we have discussed about what type of SQL questions you can expect at various types of companies, right? So in today's session, we will try to cover programming questions that you could encounter in top startups, right? Name any of the top startups in India or in the US or abroad or in other countries, or top or even good product based companies. Need not be top product based companies, but good product based companies, right? So that's where we are going to focus on. Cool. I hope the context itself is clear, right? So each of you, my suggestion here is I'm not looking for code. So the way we'll make this interactive is as follows. I'll give you a problem definition. Can you please give your thoughts in the chat window? And when you give your thoughts in the chat window, I'll look at the chat window on my phone and I'll ask counter questions, or I'll ask extensions or variations, right? The objective here is to get a feel of the programming questions itself. Again, in many of these programming rounds, some companies might ask you to write Python code, or if you're a Java programmer, most product-based companies don't care which language you write it in, as long as you can implement this, right? Some companies might just say, hey, let's just do pseudocode, right? In this session, because we have more questions today, let's do one thing. Let's focus on the logic only. We will not go into the code, because I hope all of you know programming reasonably well, that if you know the logic, you can translate it to code, right? So this should give you a good flavor of what you can expect. Okay, sounds good. Cool. Okay, sounds good. So let's see. Some of you are asking what level of data structures would we need and all that. We'll see the problems. Okay, then you will understand to what depth you need it. Cool. So here is the first question. So please read it. The question basically says, how do you implement this function called power AB? Right? Many programming languages have a function similar to this in their mathematics library, which computes A power B. right? How do you implement a power b efficiently from scratch? That's the question here. I hope, again, a question like this, an interviewer might spend just 20 minutes on a question like this, just asking you basic solution, basic optimization to this, or an interviewer could spend a complete 60 minutes on this, going into various directions, taking you into various directions. I will tell you all the directions as we start solving this problem, right? So again, the question here is implement power a comma b to compute a power b efficiently from scratch. Okay, let me write that. So those of you who are suggesting, please use import math, all that, come on. A 10th class kid can do that, right? So please give a logic behind it. Again, people who are saying a star star b, how is this implemented internally in Python? That is the question, right? Because an answer like this, or use import math and use the power function, that's something that a 10th class kid can give. Why hire a data scientist for that, right? So please tackle that. Again, some of you are giving too trivial an answers. I will ignore all those answers. Some of you are suggesting a star star b. Some of you are suggesting just use pow a comma b. This is what a 10th class kid who knows Python programming can do. There is no point in hiring a data scientist. The question here is, how is this implemented internally? If you were to implement this from scratch, how would you do it? Okay. So some of you are suggesting a simple approach. Okay, I'll take that approach, but let's go into other approaches also, right? So some of you are suggesting this approach, okay? But again, please suggest your approaches and please give some intuition on how you would do it, okay? A trivial solution that some of you have suggested, I'll take this solution. It is multiply a b times. But here you are making a fundamental assumption that b is a positive integer. Please don't forget that. Here you are assuming that b is a positive integer, like 10 or 2 or 5 or 6 and things like that. Right? If you implement like this, obviously the time complexity is order of b because you're doing b multiplications. But when you write code like this, very, very importantly, you should handle 3 cases. If b is greater than 0, first you have to check whether b is integer or not. If b is 0, this will solve. If b is greater than 0, this simple for loop, see, you can write this as a for loop, right? You just multiply this b times. So handling boundary cases is extremely important. I cannot emphasize this enough. Please handle all boundary cases gracefully. If possible, in the chat window, can you write pseudocode or at least the logic? Okay. So you have to check if b is greater than 0, then a simple for loop like this will work. If b equals to 0, you should return 1. If b is less than 0, then what should you do? Right? If b is less than 0, take the absolute value of b, do all the product and then do 1 by, right? So basic logic that you have to handle. So a lot of people, some people, okay, when I ask this question in interviews, people just go and write this answer. I tell them, come on, this is something a 10th class kid can write, right? A 10th class kid who knows Python programming, Python programming is in CBSE syllabus. So as somebody who is looking for a data science or a machine learning role, you should at least handle the boundary cases gracefully. A lot of people don't do that. They make an internal assumption without handling it gracefully, right? So please handle this. Okay, this is one solution. If you don't handle boundary cases, that's a big red flag. I cannot emphasize this enough. In most companies, if you don't handle boundary cases, that's a signal that you have not programmed enough in your life. Okay, so that is extremely important. While you might give a trivial solution with order of b, that's okay. That's okay. But if you handle all the boundary cases gracefully, you're still good. Okay. Now, while this is good, how do you do better than this? My question here is, how do you improve this solution? How do you do better than this? Can anybody suggest how to do better than this? Okay, let me see. Okay, some of you have put in this answer, which is, okay, let me just open the chat window here. I have the chat window open in another tab. Okay, so I'm happy, Shaurya, I'm happy you wrote the cases here. Okay, so you're writing a recursive function here, right? So, okay, I got it. Okay. Now, some of you are saying we will use recursion to solve it. How do we do that? Can you please elaborate how we? So some of you are suggesting that you will use recursion, right? Can you please elaborate how that recursion itself is arrived at? Can you please suggest how the recursion is arrived at? Again, when people say DAC, it means divide and conquer, right? Divide and conquer is just a fancy name for using recursion to break a larger problem into smaller problems. Okay, people like Satyam have another solution. I'll come to that solution also. Okay, I'll come to that solution. There are other solutions that people are recommending. I'll come to that. First, can you please elaborate how we use recursion here? How do we break this problem into recursion? Let me see if others have solved it. Multiply. People just say recursion without writing, at least write the recursive equation so that I know how you do it. Again, I will not be able to answer general questions now because we want to go and answer this question here. I'll tackle that later. Okay, somebody has a nice idea here. Okay, this is Nilesh. Nilesh says, let's break a power b as a power b by 2 into a power b by 2. This will not always work, Nilesh. Right? You're not handling all the cases gracefully here. Again, some of you are going into the direction of using a log and things like that. Again, Ash has a solution which is you will write a power b as a into a power b minus 1. This recursive solution is highly non-optimal. Okay, so if you use this recursive solution, okay, let me explain why. So some of you are, at least some of you are suggesting that we'll write a power b as a into a power b minus 1. See, this is highly, again, what is the time complexity of this? If you keep doing this recursion, the time complexity is again order of n. There is also an additional space complexity because recursion uses something called as the program stack. Okay, if you're not a CS programmer, don't worry about it, but at least the time complexity is not worth it. The other thing that others have suggested is they'll break a power b as a power b by 2 into a power b by 2. Again, this is not complete because it will not work in all cases. Okay. Yes, as somebody said, this will only work if b is even. What if b is odd? You have to handle all those cases, right? Whenever you write recursion, you have to handle all the cases and the resulting case. Okay, I see something from Rishikesh. Rishikesh says, okay, got it. Okay, so Rishikesh says, okay, that he will do this. Okay, Rishikesh says he will do a star a power b by 2, which means floor of b by 2, a power b by 2. Right? If you do if you do floor, if b is odd, right? Cool. Now, what is the other case? Okay, so somebody has a thing here. Let me just show this. Okay, so he says, okay, 1 second. Okay, so this is cool. Okay, so if b is even, b is odd. You should also handle the case where b equals to 1, right? Because whenever you write recursion, you break a larger problem into smaller problems, but you also have a recursive case, which is the end of the recursion. If b equals to 1, return just a, right? Very simple logic, right? Okay. So now here, when you're solving this problem, one very important thing here is, suppose you computed a power b by 2. Don't compute a power b by 2 twice. Just compute a power b by 2, store it in a temporary variable and just multiply temp with temp, right? That is a better way to use it. Okay, so let me just explain this solution because I've already written it in my notes. Okay, so let me just explain this solution. So first, let's assume that b is a positive integer. You should always handle boundary cases. You can write a power 10 as a power 5 into a power 5. You can write now a power 5. Again, remember 10 is an even number, so you're able to break it into 2 halves. Now a power 5 itself, you can write it as a square. Right? If you do 5 by 2, right? Floor of 5 by 2, you get 2. Floor, right? So you get a square. Because it is an odd number, you will multiply with one more a. A square itself, you can break it into this. So now if you notice how many multiplications are happening, you compute, so you go, see in recursion what happens, you get this, right? You're doing one multiplication here. You're doing 2 multiplications here. You're doing one more multiplication here. Right? So the number of multiplications have fallen as compared to 10 multiplications here. So if you want to actually compute the time complexity, this again, so there is one more case that I didn't handle. So it is a power b, sorry, it is equals to a if b equals to 1. So this is the recursive equation. Whenever you have any recursion problem, first please write the recursive equation. Handle the recursive case, all the recursive cases, and handle the termination case. First write it so that translating this into code becomes very, very easy, right? So once you have recursion, right, look at this. Now what is the time complexity of this? It is order of log b. Now those of you who are like, okay, where did the log come from, right? This is very similar to what we do in binary search. In our course videos, when we explain the concept of binary search, we explain how we arrive at a time complexity which is order of log b. So you have a problem which is order of b, which is broken up into two problems of order of b by 2. Now this problem which is order of b by 2 is further broken down into order of b by 4 up till you get a power 1. Right? And now once you compute a power b by 4, you don't have to recompute again. You only compute it once because you will store this in a temporary value and reuse it everywhere here. Similarly, if you compute a power b by 2 here, you don't have to recompute it again. You will just reuse it here. Right? So the number of multiplications that you will do, because there is a binary tree like structure, when you write the recursive tree, it is order of log b. Right? Very simple question. But remember, this sort of solution will only work if b is an integer. If b is positive integer, you do it as is. Again, you will handle boundary cases where b equals to 0, where b equals to negative integer. So this sort of solution will work if b is a positive integer, negative integer, or 0. But there is another case that we need to handle gracefully, which is what if b is a floating point value? Like you have a power half, right? A power 2.3, a power 6.8, a power minus 6.9. When you have, again, these are all variations of the same problem, right? So in a typical interview setup, the interviewer can start with a very seemingly simple problem, right? In a lot of product-based companies, sometimes the problem looks very simple, but the interviewer can dig in and complicate the problem in various directions. And that's what, if the interviewer wants to spend, the interviewer could spend a minimum of 20 minutes on a question to a maximum of whole 60 minutes. In 60 minutes, he'll make you implement this power with pseudocode for various variations. And some of the variations are what I'm just discussing now, right? So imagine if b is a floating point value, how do we tackle this now? So let me just go into the chat window. Good. So again, this is a simple recursion problem, right? Recursion is something that we all understand. So Deep says, please explain the equation. The equation is explained here, right? So if you notice, this recursive equation is explained here logically. You have a power 10. Whenever it is even, you break it up into 2 parts. Whenever it is odd, you break it up into 3 parts. This is the intuition, right? And this is the mathematical equation for it. Okay, sorry. So how do we tackle this? Okay, very nice idea. So somebody says we can tackle, so a power, let's say somebody says a power 0.5. So he says a power 0.5 is a power 5 by 10. Okay, very nice. What is a power 5 by 10 now? So he says a power 5 by 10 is a power 5 by a power 10. No, this doesn't make sense, no? One second. No, this doesn't make sense, no? One second. Just let me verify this. So one of you has a very nice solution. That's a solution direction that I'm going into. Very nice. So again, the problem with converting into ratios, right, is if somebody has 0.634, right? Suppose somebody has this, then you have to compute a power 634,000 and all of those complexities. Taking log is a very nice idea. Yes, so this is not correct. I understand. Shubham, I completely understand. This solution won't work because a power, so if you have a power 5 by a power 10, this is a power 5 minus 10, which is a power minus 5. It is not equals to, a power 5 by 10. Yes, that's true. It's not. So one solution that some of you have suggested just a few minutes back is to use logarithms. Again, that's a very nice solution. So if you think about it, it's a very basic concept. All of us learnt logarithms in our school days. Suppose imagine we want to compute a power b equals to x. So if you take log on both sides, remember the power of log is log translates multiplications into additions. Log converts multiplications into additions, right? Very simple. And log also converts exponentiation into multiplication. It converts exponentiation into multiplication. That's one of the most powerful ideas of logarithms. That's what logarithms are used a lot in applied mathematics and computer science for, right? So if you have a power b, write a power b as x, take log on both sides, take natural logarithm. Then if you take log on both sides, this becomes b log a equals to log x, right? This is high school mathematics, folks. This is what probably you learned in 8th, 9th, 10th classes. Now, if you want to get x here, what should you do? You should do e power log x. So what is e power log x? E power log x is x itself by definition. So e power something is often written in computer science as exp function. So if you take exponentiation on both sides, you get exp of b log a equals to x. But here comes the obvious problem. Okay, again, this sort of variation could be asked for machine learning scientist roles, where somebody might say, hey, all this is cool. We don't even have a power b implemented. We want to implement a power b from scratch, but now you're asking me for logarithm function and exp function, which are more complex functions. So he'll say, hey, what if log function and exp functions are not available? We don't even have a power b, right? We are trying to implement a power b and you're using more complex functions like logarithms and exponentiation. So what if log and exp functions are not available at your disposal? Then how do you implement this solution? The idea is cool, but how do you implement it from scratch? So let me see your thoughts here. Good. Some of you are suggesting let's use log. Okay. Okay, any suggestions for this, folks? Where log is not given to you? Again, some of you are asking, what if b is negative? Okay, so there is this question from Rishikesh. What if b is less than 0? So remember that a power minus b is 1 by a power b. So you compute a power b and you do the inverse of it. Then you will get it, right? 1 second. So Nitesh says loop using for loop b times using log tables. Where do you get these log tables now? Okay, so that's one. I'll take that. So again, this is something probably we learnt as students ourselves. Yes, using log tables, store the log table in a dictionary, all of that stuff. Okay, let's assume that is also not available. How do we do it now? No, even taking log, right? Okay, somebody, Swastik suggests let's use logarithmic series. Very nice. Remember, again, this is something that you probably have learnt in your 10th, 11th or 12th class, right? Again, very often, I completely understand most of you may have forgotten what is the expansion of log x as an infinite series. What is the expansion of expx as an infinite series? That's perfectly okay. I understand that we don't remember it, right? So in such a case, you can just ask the interviewer, hey, I think we can use this infinite series. I remember learning this in my 11th or 12th. Can you give me a hint? Interviewer most often of the times will say, hey, exp of x can be written as this infinite series. Log x can be written, again, there are multiple links here. Again, log x, depending on what the value of x is. So for general x greater than 0, look at this. If x is greater than 0, the general expansion of log of x is this infinite series. Okay, this is the general expansion of it. But there are also other expansions based on if x lies between 0 and 2, if x is greater than half, if x lies between 0 and 2a and things like that. Okay, so you can use any of these infinite series now. Now remember, when you have an infinite series, oftentimes this has happened to me many times. When I ask somebody this question, they would work out till here and they'll say, hey, I forgot log and exp function infinite series. Then I would go ahead and tell them, okay, here is the function, here is the infinite series for exp, here is the infinite series for log x. Now I tell them, please implement it now. Now here comes a very interesting case. Okay, so a lot of people just come till here. So what is our final solution that we arrived at just a while ago? Remember, what is it that exp of b log a? That's what we arrived at, right? So let me just write it down here. exp of b into log a, right? This is what we want to solve. Now, when you're computing log a, to how many decimals will you compute? Because this is an infinite series, right? Remember, this is an infinite series. I can go to x power 4 by 4 factorial. I can keep going on. It's an infinite series. So till how many values will I go here is something that you have to determine in code. Okay, that's where some of your coding skills also will be tested. So here if you are the interviewee, you can say, hey, how many digits do we want accuracy? How many digits of accuracy do we want? The interviewer might say, hey, I want 10 digits of accuracy. Then you should keep adding these terms up to the time that the first 10 digits don't change. And that is a very interesting snippet of code that you have to do. Again, this whole thing you can write it in a for loop. Remember, this is a simple for loop. For I equals to 0, or write it as a while loop actually. Write it as a while loop, start a counter, start some I equals to 0, keep incrementing it. You should keep adding these terms one after the other till the time the first 10 digits don't change. Right? So that's very, 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 very important. Okay. Similarly, when you use log or exp functions, right? Just make sure the number of digits of accuracy or the number of significant digits that you want are discussed with the interviewer, because otherwise you do not know where to stop this infinite series. You can keep going on, right? So look at this, a very simple question here, a seemingly very, very simple question of computing a power b. People can take it into all sorts of complexity, right? So first we have a trivial solution with a for loop. Then we have a recursive solution, which is more time optimal. But these two solutions only work as long as b is an integer. Next, if b is a float, we go and use logarithms and exponentiation. When you use logarithms and exponentiation, even if you've forgotten the expansion for log and exp, you can ask the interviewer, but you have to be careful on for how many terms will you perform this addition. Similarly, for log x also, there will be a number of terms, and you have to determine how many terms you want. So in an interview, it is often back and forth with the interviewer and the interviewee, right? Again, there are other complexities that can be added here. So somebody can say, hey, imagine if you are an experienced software engineer, right? Suppose you've already worked as software engineer for 4 or 5 years. Then if time permits, let's assume the interviewer wants to ask only one question. He has asked, you've given the trivial approach, you've given the recursive approach, right? You've also given when b is float, right? So these are all variations. Next thing that the interviewer can say, hey, how do you implement it using multi-threading, or how do you speed it up using multi-threading, or how do you speed it up using multiprocessing, right? How do you speed it up using suppose imagine if you have an 8-core processor with 16 threads, how can you speed it up, right? So the interviewer can just spend whole 60 minutes on just one problem so trivial solution, what is it testing? Let's ask ourselves, what is it testing? He's testing whether you can handle boundary cases gracefully or not. Here he's seeing whether you know about basic concepts like divide and conquer and recursive algorithms, and do you understand the concept of time complexity, and can you improve it? With this variation, he's testing if you have the mathematical grit, if you can think from mathematical perspective. If you're an experienced software engineer, he'll say, hey, can we speed it up using multiprocessing, right? Look at this. Each of these questions is single question. He can test 4 or 5 skills that you have. Again, when I was an interviewer at some of the top product-based companies, this was my strategy. I would take only one question, one simple question, but I will ask so many variations and so many extensions of this that, again, if you are other variation here is, if you come from a maths background or a electronics background or some of those non-CS fields, I will say, what if A and B are complex numbers? Especially if you come from a math background, right? So there are so many variations that you can arrive at just from this single question, and I can spend a whole interview and evaluate multiple skills, not just one skill. I can evaluate your mathematical skills, your skills of basic recursion and time complexity, your skill to handle boundary cases, your skills to write multiprocessing code, right? So all of that we can test in just one question, right? So a key takeaway here is this. The key takeaway from this example is, whenever you're using an inbuilt function, just pause for a second and think how some of these common functions are implemented. These common functions you might encounter in the math libraries. Like Python has a math library, right? Like power itself, POW A, B is an inbuilt math library, right? So ask yourself how this can be used here. Similarly, if you are using pandas and SQL, right? So in SQL you have operations like joins, group bys, all of these things, right? Very commonly implemented. Ask yourself, how is a join implemented internally? This used to be one of my favorite questions, especially for data scientist roles. I would say, hey, how would you implement join? And I would even ask like very senior engineers, how would you implement join in a distributed system if somebody came from a Hadoop or a Spark background, right? Or ask yourself how some of these basic inbuilt data structures like a list would be implemented internally, right? How a hash table would be implemented internally. So ask yourself these basic questions so that your understanding of some of these functions would surely improve, but you will be much well prepared to tackle interviews at product-based companies, right? I hope this gives you an idea of what some of the things that you might encounter in the real world. Okay. So again, so one of the questions that's coming here is, what if somebody is from a non-math background? This question doesn't require a math background. This is high school math, folks. Okay. This is something that we all learned in our high school. This is just testing if you can solve real problems in the real world. Can you solve problems by using high school mathematics? This is simple high school mathematics. Recursion is something that is so basic to programming, just like for loops are, right? So please remember that this is very, very important. Again, one more very interesting point that came up was that one of you is suggesting, which is I think Shubham Ale is suggesting, computing these exponent series itself uses this exponentiation sometimes. Yes, that is true, right? But remember that this is just this exponentiation. Okay, that's a very good boundary case that Shubham Arle pointed out, which is, hey, to compute this exp function or log function, we are having the exponentiation here itself. Aren't we just going round and round? No, because this exponentiation is an integer exponentiation, right? So this is an integer exponentiation here. So we can write one function using the recursion approach for integer exponentiation. Actually, we don't even need to do that, because if you compute x power 1, we can compute x power 2, we can compute x power 3, and so on and so forth, right? It's a good question that you asked. Very nice question. But remember that these exponents are integer exponents. Okay. So again, let's think about Rajat is asking, can you please give some idea on how join is implemented? Think about it. A hint is you can use hash tables to come up with some very nice solutions to do a join. Okay. There is also brute force join, but think about it. Okay. Cool. Sounds good. Sounds good. So very good. So the problem here again, now the question is, okay, how do you compute the, so here is an interesting follow-up, which is, how do we compute the time complexities of this? Right? That's a good question. The time complexity of this depends on how many digits of accuracy we want, right? Because these we'll have to write this in a for loop, right? We'll have to write this in a for loop. And there are some expressions that you can arrive at, but they're fairly complex. Most people don't go too deep into a concept. Okay, unless you are a PhD student in algorithms or a PhD student in numerical methods. Unless you come from that background, most interviewers won't go too deep into it, right? Again, the interviewer's job is to just check if you can work out the details. Cool. Very good. So let's go here. Okay, so that's a takeaway. Okay. Again, somebody is asking, how do we tackle the join question? You can use loops. It will be non-optimal. Then you can use some inbuilt data structures like hash tables. Try it out. Take your time. Try it out first. Okay. So let's tackle the second question now. Okay. We have spent about half an hour on this question. So let's tackle this. This is a very interesting question. So here the question is also very simple. How do you implement this function? So you want to implement a function that computes AUROC, right? It is the area under the receiver operating characteristic curve. Okay. Imagine you're given a function, you're already given, so you have a model that you have trained. You pass a data point x to this, it will return y hat, which is the predicted value. So this function already exists. Imagine that there is a function that exists here and you're given some data set. Okay, you're given some data set of xi, yi pairs. Okay, let's assume some n points. You're given some n points You already have a model that is trained. You want to write a function which implements AUROC. Whenever somebody says, please implement a function, always ask yourself, what are the inputs? What are the outputs? How do we arrive at the output from the input? Again, these types of questions are also very interesting because in a single question like this, the interviewer can test both your programming skills as well as your ML knowledge. I really love questions like this because in a single question, I understand if you can program, I also can test if you have machine learning knowledge. Here, basically, I'm saying, hey, do you know how AUROC is computed? Instead of giving me the logic, write the code or at least write the pseudocode. So in one question, I'm covering both programming and ML knowledge. And that's what interviewers want to cover. Especially in the initial rounds, interviewers may say, hey, let's cover multiple things to see where the candidate stands. Can you give me some logic around this? Okay, I see some interesting ideas. So some of you who don't know what is AUROC, it is one of a very popular metrics in binary classification tasks in machine learning. Again, this whole concept here is, okay, if you don't know what is an ROC curve, then you cannot answer this question, right? So this is a receiver operating characteristic curve. It's often written as AUC, area under the curve for the receiver operating characteristic. Okay. Okay. Again, there are multiple parts to the solution. When you have to implement this in code, first break this problem into multiple subparts. Maybe you can say, hey, first part is this, second part is this, third part is this, fourth part is this, and break it down, write the pseudocode, explain it. Again, many interviewers, again, depending on that, again, this question could be a whole 30 minutes question. I've been in interview loops where I've seen people give some concept like this and they'll say, hey, please implement it and while you're implementing it, they'll keep asking you follow-up questions. Okay. Okay, so I like the approach that people are going to. Okay, first sort the data. Okay, so let's go step by step. I really like the step-by-step approach because then you can translate it into code, right? So for those of you, again, first and foremost, always please write down what we have. So your inputs could be xi yi pairs, right? Xi yi pairs, or again, if you're given xi and yi pairs, from xi you have to compute yi hat using the evaluate function, or your input could be yi and yi hat pairs. That's also a valid input, right? So your input could be this or this, and your output is actually a number, which is the AUROC. Again, when you're doing this, first always draw diagrams. Okay, what is your AUROC? AUROC is you have TPR on the y-axis, you have FPR on the x-axis. Okay, and you have this whole curve here. You have to find the area under this curve, right? So that's the task here. Of course, you're not given this curve. First, you're given only xi yi pairs, or you can say I have yi hat pairs. So you can say I have yi hat pairs for all I equals to 1 to n. Okay, so let's take this, right? Because if you're given xi, you can compute yi hat using the evaluate model function. So first step, as some of you suggested. Okay, so I'm happy. So it's, again, I'll tell you one thing. I've seen this in a lot of interviews. When I ask this question as a general question, people give me all the answers. People will give me a general idea. But when I tell them, please write the pseudocode for it, I see a lot of people blocking. That's very, very important. Like I've asked this question in some of our mock interviews for students also. Okay. So remember, interviewers also know this. Interviewers must have done hundreds of interviews. They know what you're saying. Okay. Whenever interviewer says, hey, please write pseudocode for this. Okay. Or write some Python code for this. They could say, just write Python code for this. Or implement it in Python code from scratch. What they're basically asking you here is they're testing, do you know the guts of it? Do you know the internal workings of it, or you've just remembered the high level concepts and you're telling me in the air? Because it's very easy for machine learning concepts, again, at least some concepts like this, where people just remember a few facts about these things and just blabber that out in interviews. I've seen this, by the way. So when I ask this question to candidates, it's at least not all, sorry, but only some candidates, they just tell me, okay, we'll sort it, we'll do this, or they'll just say, hey, we'll sort it, threshold it, compute the area. Then I say, okay, please write the pseudocode for it. Then they start getting stuck because their thought process is not fully clear. Okay. So first step is you sort yi hats in ascending order, right? So in ascending order. So let's assume the yi hats are between 0 to 1. You start from 0.00, go to 1.00. So you go in this sorted order first, right? You go in this sorted order. So when you go, so you'll have n values here, right? Remember, you will have n values here. At every value, take it as a threshold. For every threshold, so when you do a threshold, what are you saying? You're saying all these values are class 0, all these values are class 1. Then you have to compute what is FPR, you have to compute what is TPR. Look at this. So you will have to implement two sub-functions called FPR and TPR. First, you will sort this. Sorting, fairly simple sorting. Again, you can ask the interviewer and say, hey, can I use the inbuilt sorting function? Most often the interviewer will say, hey, please go ahead, use it. Okay. Then you have to write a for loop where for each of these n values, you will threshold. And for each of these thresholds, you have to write a sub-function called compute FPR and compute TPR. Now here, what the interviewer is testing is, can you write the code to compute FPR and TPR clearly? That's very, very helpful, right? Think about it that way, right? So the interviewer is basically testing, can you write the code to compute FPR, TPR, right? So when you write the code for FPR, TPR, you get a list of FPR, TPRs. So the way you store it in Python, again, here people will test your Python knowledge or your understanding of inbuilt data structures. Okay, so they can simply say, hey, we can use a tuple like this. Tuple is a data structure, right, in Python. So you can create tuples like this where you'll store each FPR, TPR value you get for each threshold. And all of these tuples, you can store it in a list. Right? Look at this. So I'm also testing your knowledge of or your ability to use inbuilt data structures in Python. Right? As far as most machine learning data science roles are concerned, if you know the inbuilt data structures, you are good, unless you have prior software engineering experience where other data structures and algorithms could be asked. Okay, simple logic. So first step is sort in ascending order of yi hat. Second step, create a for loop, threshold everywhere, write two sub functions called FPR, TPR. Most interviewers will say, hey, go ahead, implement FPR, TPR functions and store all these values, arrive at these values, which is basically a list of tuples of FPR, TPR. Again, a lot of interviewers will ask, hey, to store this data, what data structure will you use? They're trying to test if you can think and apply your knowledge of basic data structures in Python and see which data structure to use where, right? So next you want to calculate AUC. So now you have this TPR. So you have T1, F1, you have T2, F2, you have these pairs now, right? You have a list of these tuples, right? You have T1, F1, T2, F2, so on and so forth. Now you want to compute the area under this curve. How do you compute the area under this curve? Here comes the other mathematical part. Okay, what is the area under this curve? The area under this curve is if this is your FPR I and FPR I plus 1, right? So let's assume this is one FPR, this is the next FPR that you compute. You will get TPR I plus 1. Imagine if you can compute the area under this part of the curve and you add it to area under this part of the curve and you keep adding it. This is basically what are you doing here? You're doing integration as a finite sum of small areas. This is what integration means fundamentally. Right? Again, in this problem, lot of things are getting tested. This is testing your understanding of, do you know what integration actually means? We all say, hey, we use AUC, let's compute AUC. But do you know how to do that internally? It is testing that foundational understanding, foundational mathematics here for you. Now, if you want to compute the area of this, there are multiple strategies. One of the best strategies is something called as a trapezoidal rule. Okay, let's assume, see, let's only take this part, right? Let's only take this part. Let's try to compute the area of that part. Right, this is your FPR I, this is FPR I plus 1, this is TPR I plus 1. Now, this is the actual curve that you have, right? So, what you'll do is you'll approximate that curve with this trapezoid. So, this whole structure, this line, this line, this line and this line, this whole thing is called a trapezoid. You can break a trapezoid into two parts, one triangle, right? This is one triangle and this is one rectangle. So you can take you can compute the area of this rectangle because this is the width, the height is this Ti, right? You can compute the area of this triangle and you sum up both of them, you get the area of this one chunk. You get the area of this one chunk. And then you keep adding it from 0 to 1 because you know FPR ranges from 0 to 1. Right? This is basically simple integration trapezoidal rule. Again, while this question might seem simplistic, remember the interviewer is testing multiple skills in a single question. This type of question, an interviewer can spend 30 minutes. They might cover 2 questions like this, which is a typical good product-based company interview. Right? So what are they testing? First, they are testing if you can break down they are testing, do you know what AUROC is and do you know how to compute it step by step? Okay, there are multiple things. Sorting, straightforward. Here they are checking if you can write simple for loops. It's slightly tricky, but it's not complex. Can you just write simple for loop for in each of the iterations? Can you take a threshold? Do you know how to compute FPR, TPR? This is another thing that is being tested. Can you use an appropriate data structure to store this data? Another very important thing that they are testing. The fourth thing that they're testing is your mathematical understanding of foundational concepts in calculus like integration and differentiation. Very simple concept, right? So again, all these things, again, applying the trapezoidal rule, you have to be very, very careful when you apply the trapezoidal. It all boils down to writing a for loop. But an interviewer can say, hey, please go to the whiteboard or open the Google Doc and write the whole code in whatever language you want. They'll obviously test if you're handling all the cases gracefully, if you're writing for loops, if you know the basic concepts. And if you can implement this in like 30-40 minutes, you're a pretty decent programmer as far as machine learning roles are concerned. Right? So the key takeaway from a question like this is this. Learn to implement ML functions from scratch. This is very, very important. If you really want to know how machine learning algorithms work, try to implement them. That's why in some of our assignments, like we have some assignments where we make people implement things like compute FPR, compute TPR from scratch. We make them implement a logistic regression with regularization from scratch without using any libraries. We make them implement backpropagation from scratch, backpropagation in deep learning from scratch. Some people ask us, hey, why do we care about it? Because interviewers care about it. And why do interviewers care about it? Because if you know how some of these basic machine learning functions work, it is guaranteed that you know the underlying stuff. Because in a single question like this, they can test your ML knowledge and they can test if you can program well. Because if you can implement something like computing AUROC well, you're a pretty decent programmer. You're a pretty good programmer actually, if you can do it reasonably well, right? So that's something that you have to be careful about. Again, any ML function that you have, any machine learning function that you have, think of how you would implement it. Right? So that's very, very important. Again, there might be some questions where time complexities may not be very important. Okay. So for example, look at this. Again, people could ask that. First, you're sorting you have n values that you're sorting. To sort n values using some of the best algorithms, it will be order of n log n. Right? Then you're doing a for loop. So just the sorting part itself is n log n. Right? Then you're doing a for loop here. Right? So which means it will be again order of n here. And for each of the times you're doing this, you're computing TPR, FPR, right? So you can work out the time complexity step by step for it. Again, the integration, this integration that you have, right? You will only have at most n FPRs and n TPRs, right? So this will also be order of n here. So you can work out each of these details, but in problems like these, it is less about time complexity. It is more about, do you know the machine learning concept? And can you translate it into actual code step by step, right? Questions like this, it's less about time complexity, but some people could ask time complexity also. I'm not saying they would not, but less often. Okay, I hope this is cool. Okay, so whenever you learn, if you really want to be a good machine learning engineer or a data scientist, always ask yourself, how do I implement this from scratch? Again, in some interviews, I've asked people very simple questions. I asked them, implement k-means. Implement k-means. I've been in interviews where I just ask people, implement k-means in, like, it's a 30-minute question. Let's implement k-means from scratch. And I see people who can tell me everything about k-means who can't actually implement the code. Because while they implement it, I'll find 100 bugs in the code or 100 cases. So please, that's why even in our course videos, whenever we explain a concept, we often write pseudocode for it. Look at SGD, right? We write pseudocode for SGD. Again, you can write pseudocode, or even if you know the math equations, that's good enough, because you can easily translate mathematical equations into pseudocode and then to code, right? It's very, very important. I cannot emphasize this enough, right? In lot of interviews that we conduct, we do ask candidates in mock interviews, even I have friends at other companies, at top product based companies. This is a very interesting question that I've seen some of my friends ask. Everybody says, hey, I've used LSTM for this, all of that stuff. Do you know one question that I really like that question? They say, can you implement this function called LSTM forward propagation? Can you please implement this function from scratch? So they'll simply say, hey, what all inputs do you want? What all outputs does it generate? And explain me, write a pseudocode, write actual pseudocode for forward propagation of LSTM. And they'll say, hey, can you implement LSTM backward prop? What are the inputs? What are the outputs? Write down the pseudocode for me. Or at least write the mathematical equations and give me justification why is it so. Okay. Again, these are some of the top product-based companies where people say, hey, I've used LSTM, all that. Most people don't know, unfortunately, how LSTM works internally. So to test that, I have friends of mine who just ask this. They take some basic concept. Like I know people who ask, okay, can you explain me how max pool layer, right? In our course videos, we have some of these functions that we ask people to implement as part of assignments after explaining all the concepts. So I know people who say max pool forward prop, how do you implement it? Right? Very nice question. Similarly, max pool back prop, how do you implement it? When you know how to write pseudocode and justify each of the steps, that means you know the system. You know how it works internally. It's a very nice test that interviewers sometimes ask. Okay. Cool. So let's go to the third question. Okay. So this third question is a slightly different question. So please bear with me. Okay. This question is more of something called as a low-level design question. These types of questions are typically asked to candidates who have at least 3 years of software development experience. These questions are not asked for freshers. These questions are not asked for people who come from non-software engineering background. But imagine if you worked as a software engineer for at least 3 years, right? And you're interviewing for a machine learning engineer role, or again, these types of questions are often asked for machine learning engineer roles. Let me also make that clear. These are not asked for data scientist roles. And again, if you're a software engineer with 3 years experience, a machine learning engineer is the most apt role, because you're taking all the skills of yours as a software development engineer and moving into machine learning. It's a very nice question. I've asked this to candidates with 3+ years experience. The question, again, this is a fairly open-ended question. Like you can spend a whole 60 minutes on this question. Typically people spend 30 minutes. And there is no one right answer for this question. It's a very design question. The challenge with design questions is there is no one right answer. Okay, because based on the answers that students give, the interviewer will take you in various directions. I'll give you some nice pointers as far as this problem is concerned. So this question is very nice. Imagine if you want to implement a class called tensor. Some of you are asking, are object-oriented programming concepts important? You should know the basics of object-oriented programming. Again, we have discussed this extensively in our live sessions, in our course videos, etc. But if you're a software engineer with 3+ years experience, you have to know object-oriented programming very well. Okay. So the basic if you do not have this sort of experience, a software development engineer with 3+ years experience, a functional knowledge, understanding basics of object-oriented programming, as we discussed in our course videos, is more than sufficient for most roles. Okay. We can never say they're sufficient for 100% of the roles. For most roles, they're sufficient. Okay. So let's go to this class tensor. How do you implement this class tensor from scratch? Okay. So it's a design question. Okay. Nancy is asking how to solve this problem without ML. All these questions are very specific questions for machine learning roles. These are not for general software engineering roles. Okay, somebody is asking, what is a tensor? Okay, you should know what a tensor is if you're coming for a machine learning interview. Okay, so tensors are like, you have, this is a vector, right? This is a vector, right? Vector is like an array. This is your matrix, right? Then you have 3-dimensional matrices like these. You have 4-dimensional matrices, right? You can have 5-dimensional matrices. Any of these n-dimensional matrices, tensor is a general term for all of them. right? Just like the way you have vector, matrix, tensor is a generalization of that. Yes, I'm happy. People are asking the right questions. So Shubham is asking, what features do you want in the class tensor? Good. This is the first follow-up question you should ask. You should ask your interviewer, hey, what do you want my tensor to do? What do you want it to do? Okay, that's a very good question. So let me answer that question. Okay, so I could say, hey, I want to store all the values in the tensor carefully. I want to, of course, modify the values of my tensor, right? I also want to apply some basic operations on tensors. Okay, some basic operations on tensors. Okay, I want to apply some. You can pick any operations that you want. Let's try to implement at least 2 or 3 basic operations. Yes, so very nice. Anuj is saying, hey, this is very similar to an ND array, right? Yes, this question comes from that. This question comes from that. So in NumPy, all of us use NumPy, right? More or less. All of us use ND array. All of us use ND array without thinking how ND array probably was implemented. So especially for software engineers with 3+ years experience, they should think, again, this is called an object-oriented design or low-level design question. You should ask yourself, whenever you see a data structure or a class like this, ask yourself, read the documentation, very importantly, ask yourself, how is the data stored internally? Again, we have discussed ND array documentation in lots of detail in the course videos, right? So that's what it is. So it's NumPy ND array is one of the best. There is a research paper that the NumPy group published in Nature or Science just a few months back. Wow, it's a mind-boggling research paper. Of course, I learned a lot about ND array myself by reading the documentation itself. But this is a design question. Okay, let me just... okay, by data pre-processing, I didn't say data pre-processing, right? Again, Tanmay says, how many dimensions are we considering? It could be any number of dimensions. It could be any number of dimensions. When I'm creating a tensor object, I can say, I want a 10-dimensional tensor. You should be able to create it. I could say, hey, I want a 1-dimensional tensor, which means it's going to be like an array. I could say, I want a 2-dimensional tensor, which means it's going to be like a matrix, right? Again, that's one of the things that you should do in the constructor of a tensor, right? So these are, again, these design questions based on answers people give, the interviewer can take you in different directions. Let me give you some general guidelines to tackle questions like this. First question you should ask is, what operations are going to be performed on this? The interviewer might say, hey, pick 2 or 3 operations of your choice and let's work it out. Okay. Then you want to say, what are the most common, most often performed operations, because you want to optimize it for these operations. You want to optimize it for these operations, right? Whatever you write, however you design this ND array or tensor, you want it to be most optimal for the most common operations. Now, the next question that you should try and tackle is, how do you store this data itself? How is NumPy's ND array data is stored internally? Ask yourself, how is it stored? Remember, okay, so you might say, hey, I'm a Python developer and I've come for this role. I know machine learning, all of that stuff. Then the interviewer will say, how do you store the data efficiently in Python? It's a very good question, right? Think about it. How do you store this data? Okay, so Venkatesh is suggesting that he wants to do a dot product, multiplication, addition, subtraction. Okay, let's take those operations, right? So you want to take a dot product or some form of product. Okay, you want to do addition, subtraction, basic stuff. Okay, so let's assume, or you want to do element wise product. Okay, you want to do element wise multiplication. Let's assume these are the operations that you want to tackle. Now, how do you do it efficiently? Very importantly, how do you store this data? How do you think NumPy stores the data internally? You can't use NumPy, Anuj. You should say, the question here is, how do you do it from scratch? Look at the question. The question says, design a tensor class from scratch. Okay, so some of you are suggesting, how do you store this data? Some of you have some interesting ideas. So they're saying nested list. Okay, seems like a decent option unless you go into the depths of it. So data structure is array, but how do you store? So some of you are suggesting even dictionaries. Okay, interesting. But then, does anybody know how NumPy data is stored internally? We have discussed this in some of our live sessions. Does anybody know how NumPy's data is stored internally? This is the difference between a good engineer and not so good engineer. Let me tell you that. Okay, so Shubham, let's assume it is dense matrix for now. Okay, because let's not assume it's a sparse matrix or a sparse tensor. Let's just assume dense for now. Okay, so if it's a sparse data structure, using dictionaries makes sense, right? So that's a different topic onto itself. Okay, but let's just stick to this. How do we store this data? How do you think NumPy stores the data? If you've ever read the documentation of NumPy, let me show you the documentation of NumPy. Good. I'm liking what people are saying. So remember, when you want to implement something mathematically heavy, Python often implements it in C. Python actually uses C programming language. Lot of these operations, again, we have mentioned this in multiple live sessions we have conducted. The reason these operations are so fast is because they're actually implemented in C. Within C programming language. Again, here I'm assuming that you're a software development engineer with 3+ years experience. Okay. In C, they're actually done using dynamic memory allocation. Dynamic contiguous memory allocation is what is used. Because C is super fast with allocating memory. So what you have is basically a chunk of memory. It's basically a huge array. Literally, that's what it is. Okay. Or you can, again, this is a dynamic array. Of course, there are some implementations. You can do also implementation using linked list, or you can use basically dynamic arrays. Again, there are variations between both of them. There are pros and cons. That's a whole discussion onto itself. But in general, the key here is Python is very slow for numerically heavy operations. So you should always interface it with C code. And as somebody with 3+ years experience, I'm assuming you know at least the basics of C programming language and how you can optimize it. Again, you can spend, I can spend 60 minutes just on the storage choices that we have and things like that. Again, some of this, if you actually go through NumPy's documentation, NumPy Andy array data. What is it? Okay, done. Why is it doing this? Okay, I think it's a bug with my, just a second folks, preferences. Toolbar, just a second. Okay, it's gone now. Okay, yeah. So NumPy ND array reference. It's actually, if you read the documentation of NumPy ND array, it actually tells you how this data is stored actually. So you can see, look at this. It can use buffers and all of that stuff. If you just go, again, my suggestion is, see, look at this ND array, the previous topic, constructing arrays, indexing arrays. So if you have ever read this, it also discusses a lot about how this data is internally stored, all of that stuff. Look at this, it stores using a buffer of arrays, all of this stuff. Okay. So whenever you have time, at least read the basic documentation so that you understand how some of these concepts can be implemented in a design question. Then you have to talk about how operator overloading, how you will implement operator overloading. You have to ask yourself, okay, how will the constructors be? So what all constructors? So the interviewer is not looking for exact implementations. He's basically looking at how do you implement the constructor? What are all the parameters that you will have in a constructor? And why? What are the multiple types of constructors you could have? Okay. What all operators will you overload? Like you might want to overload plus, minus, star, right? You might want, or exponentiation. You want to do operator overloading for some of these. Again, it's going to be a very open-ended discussion. He might ask, okay, what are the private members? What are the public members? What are all the data that is going to be stored? Okay, you could have one buffer, one data buffer, right, where you'll store the actual ND array. Then you might have the dimensionality, right, because you want to know how many dimensions tensor it is and how many. So suppose imagine if you have a matrix, right? Matrix will have m cross n. This m and n also have to be stored here. Then you might need a list here. You might need something like a list to store. Imagine if it's a tensor with 10 dimensions. This is a 2-dimensional tensor, right? Imagine if the dimensionality is 10, you need a list of size 10 here, right? So what all stuff do you do in a constructor, right? The interview can go on in many directions. Then the interviewer can say, hey, how will you implement optimally at least the common functions? How will you implement, let's assume you have 2-dimensional stuff. How do you implement dot product efficiently? Right? How do you implement dot product? How do you implement element-wise product? How do you do addition efficiently? He can go on and say, hey, how do you implement these using multi-threading, using multi-core processing, all of that stuff. Then he can go on and say, hey, we know that iterators and generators are a very important concept in Python. What sort of iterators will you write? How would you implement it? So this can be a whole 1 hour discussion onto itself, right? Again, you could have, this interview can be just 3 hours just on designing a class called tensor. Okay, but these are the directions that you should think of. Very importantly, why are we designing this? What operations will we perform? What are the most common operations? How the data is stored? What all operators do we overload? How do we have all the constructors? What are the public members, private members? At least optimal implementation of a couple of operators, iterators, because iterators and generators are a very common concept in Python, right? So this interview can go on in many directions, right? So again, I'm not saying, and this depends a lot on the answer that a candidate gives. Okay, so what this is testing is, as a software engineer with 3+ years experience, who is coming for a machine learning role, right? So this is an interview for a machine learning role. Can you actually, because you already have a software engineer experience, if we hire you as a machine learning engineer or even a senior machine learning engineer, can you actually implement some of these low-level design stuff? Do you, again, these are stuff very similar to libraries that you may have used. So the key takeaway from this sort of exercise is this. My takeaway that I would recommend here is read documentation of libraries that you do. Especially if you're a software engineer with 3 or more years of experience, think of how that library was designed. This is especially true for software development engineers with 3+ years experience. Right? Imagine if you're a Java developer with 3+ years experience. Come on, you must have written so many classes, objects, all of that stuff, right? You should know this. You should be able to think from that perspective. So whenever you're using libraries, please read the documentation, understand what is happening under the hood. Especially if you're a software engineer with 3+ years experience, ask yourself how some of these things are designed internally, not just implemented, but designed internally. Okay, sounds cool. So let's go to the, okay. Let's continue in this. We have one more question, then we'll do a general Q&A. Okay. Again, this question can be modified in many ways. So somebody is saying, Karthik says, anywhere can we see the implementation code of libraries? Most libraries are open source. You can go and read the implementation yourself. So Anuj says, encapsulation, all that stuff. Yes, that's true. In the previous problem, there is not much of inheritance, right? All of that stuff is not there much because we are just designing one class. Okay, cool. Sounds good. So write a function to generate the first 10 most significant digits of n factorial. That's the question. Again, I'll take the general questions later, but let's tackle this question first, please. Again, somebody is asking, where can we see the implementation of libraries? Come on, guys, that's right staring at you. For example, take this, right? Take any library. Take your favorite library. Let's assume, let's take Python math power function, right? Let's look at this. Okay, so math.pow, right? So that's a function. So math.pow GitHub. Okay, let's see. I think we should get it. Okay, topics math.pow. Not this. I should say Python. Just a Google search away. Okay, Python, C, Python. Okay, this is the source code. Yes, so somewhere here you will find the implementation of, this is the C implementation, by the way. Yeah, a lot of this math heavy stuff, math.pow. Okay, so here it is. This is math.pow. Okay, math.pow implementation. Yeah, so look at this. Some of the details are here. Again, this is implemented in C. Remember, a lot of the heavy duty mathematical stuff is implemented in C. All the boundary cases are handled very enough. This is like world-class implementation without doubt, right? So it's just a Google search away. So most libraries, whether it's NumPy, whether it's scikit-learn, whether it's TensorFlow, most implementations are just a Google search away. Just add this thing called GitHub at the end. Okay, then because most of these open source libraries are actually hosted on GitHub. It will require some tinkering around, but you will be able to find it. Okay, that's what I would recommend. Okay, let's go tackle this question. This question says, it's a very slightly tricky, twisted question. We don't want all the digits of n factorial. We want only the 10 most significant digits of n factorial. How do we do this? Okay. So, okay, somebody says, what is the 10 most significant digits? Okay, let me show you an example. Okay, let me just show you an example. Okay, suppose if I want to do 100 factorial. Actually, this is done at Google. Okay, on Google search, if you type 100 exclamation, which is a mathematical symbol for factorial, it says 9.332622 into 10 power 157. So what is it giving us? It is giving us 7 most significant digits. Okay, most significant digits are the first digits in the whole answer. Least significant digits are the last ones. In 100 factorial, some of the least significant digits will be zeros. Right? You can verify that if you want. So I want these first 10 digits. That's what I'm looking for. So imagine if you're trying to build this, right? Suppose you're working at Google, you're an engineer who's responsible for implementing. Whenever somebody has this, you want to give this answer. Suppose your response, or forget about the whole 10 power something, you want to give at least this part. That's what I'm asking. This is a sub problem of what a Google engineer probably implemented. Okay, cool. I'll come to general questions later. Okay, I hope this answers your question. So one solution that people are giving is, okay, cool. So very nice. So you're just writing a for loop, right? You're writing a for loop. You're multiplying n with n minus 1, so on and so forth, up to 1, and you're returning this value. Here are a few things that you should do. Very, very importantly. Again, this is a programming round, so always write down the boundary cases. Right? Always write down the boundary cases. Okay? Your n should be greater than or equal to 0. N should be an integer. Right? N should be an integer. N should be greater than or equal to 0. Of course, 0 factorial is 1 itself. Right? Yeah, 0 factorial is 1. Yes. Yeah, it has to be. Otherwise, things fail. Okay, so this solution is reasonable. As long as you handle the boundary cases, this is a reasonable solution. No doubts about it. But this will run into a problem if n is large. Let's assume n is greater than 100. Okay, so let me ask you a question. So somebody is saying recursion is also possible, but recursion is highly non-optimal, right? How will you implement this with recursion? You'll say, hey, you can implement this with recursion, but then what happens with recursion is the time complexity doesn't change, right? There are n multiplications here. In recursion also, so this is order of n, right? Recursion, if you implement it with recursion also, it's order of n. So not much of advantage, but recursion has an overhead because of keeping track of what function called what. Okay, that's called the function, that's called the program stack, which gets filled. Okay, so not much of advantage using recursion here. Okay, the big problem that happens here is, yes, it should be, that's what I said, no? N should be, yeah, n is greater than or equal to 0 and n is an integer, which means n is a positive integer, right? Recursion is possible, but it's highly non-optimal. No point using recursion here. Now, another question I have here is, this solution, as some of you suggested, works. But in Python, okay, let me ask this question. In Python, if let's assume n equals to 100, what happens? Will it work in Python? So, okay. So will it work in Python? Think about it. Actually, if you write code, it'll end up working in Python. So because Python stores, so the problem here is this. Okay. So when n is large, what happens here is you have something called as an overflow problem. So those of you who come from Java background, C background, understand this. Okay. So what happens in most non-Python, so Python has a trick up its sleeve. So when n is large, the n factorial is also going to be a very, 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 very large number. Okay. So when n is a very large number, what happens then? Then the tricky part here is you can't store it in an integer data type or in any data type. So what Python does is Python has internal implementation of something called as big integers. Okay. So Python, as soon as the number becomes too large, it starts creating something called as a big integer. Okay. But imagine I want you to implement this from scratch without using this inbuilt, or I ask you, how is this implemented internally? Okay. Imagine the question. So there is an overflow problem. Okay, which means you will not be able to store it. As one of the students suggested, he has a very nice idea. He'll say, I'll store this as a string. Right? So one of the things that one of the students suggested, I think is Rajat. Very nice idea. So as I keep multiplying n with n minus 1, n minus 2, as the number becomes large, I will store it as a string because my string can be any long. Okay, I'll actually store this number as a string. Very nice idea, Rajat. Very interesting. But the moment you store it as a string, there is one problem that you'll have to tackle, which is, look at this. Imagine if I store this as a string, 1, 2, 3, 1, 6, 2, 1, 0, 0. Let's assume we have this as some number. We are multiplying numbers, somewhere in between we get this. This, if you want to multiply with, let's say 12 or 30, some other number, you have to write a custom function. You have to write a function which multiplies a string with an integer. You have to write that function yourself, which means you're implementing, remember, you're writing a function which takes a string, which takes an integer, let's call it x. You have to multiply this string with integer and it should return another string. So in the interview will say, hey, please implement this function now. It's a nice idea, very, very nice idea. Surely, no doubts about it. But you will have to implement it yourself. Okay, so this is certainly a nice idea, no doubts about it. But there is another idea which is also very good, which is often used. Okay, so a number like this, instead of storing it as a string, it is stored as a list. Remember, I can keep increasing the size of the list. So I'll take a few fixed digits here, maybe 3 digits, 5 digits, 10 digits, whatever it is. I will store it as a list like this. Now storing it as a list makes life simpler for me. Now remember, implementation becomes simpler. If I'm storing this number, imagine this is a long number which I can't store it internally in integer data type. Okay, then I'm storing it as a list of integers. Now if I want to multiply this, I have to multiply this with 12, right? Write the result and carry forward. So this is like, so as kids we learned this, right? How do you multiply 132 into 12? 12 3s are 36. 6 we write here, we carry 3, right? 12 2s are 24, plus 3, 27, 2. 12 1s are 2, plus 2, 14. This is the multiplication that we learned as kids, right? The same multiplication, but here you have multiple digits here. Okay, implementing this is the trick behind this whole game. The trick here is just to implement this. Implementing this carefully, or as Rajat suggested a while ago, implementing the string multiplied by this function, which multiplies a string with an integer, implementing that carefully is the trick here. And it's not hard. It's just a simple for loop, but you have to do it very, very carefully. So you have to multiply these numbers, take only 3 digits, carry the rest of it here, multiply this, sum it up, multiply these two, add the carry, again place it here and keep increasing it. So here you might have only three numbers here, but the result could have 4 numbers. So you have to keep adjusting these lists very, very carefully accordingly, right? So that's, again, it's not a hard problem. It's a simple problem. 20 maybe 25 minutes you can solve this. Write actual working code for this. So for questions like this, interviewers will ask you to write actual working code in a modern programming language. Okay, now my question here is this. The moment I went to Google, I typed 100 factorial. Google instantaneously gave me this result. Almost instantaneously, right? Google gave me this result very, very fast. How do you think Google gave this answer very fast? Any suggestions? Right? Google gave this answer in like less than 1 second, probably in a few milliseconds. I think Google also works for 1000 factorial. Let me try it. I've never tried it. Just let me try it. Give it a shot. Undefined. Okay. 1000 factorial, it's not doing it. Okay. Because probably Google engineers have a threshold. They say, aha, it's not even doing 200. Okay. I never tested what is the stress value. 150. Oh, it's giving 150. Does it give 199? It's not giving 199. Till what value does it give? 178? No. 175? It gave 150, right? So 151. So we can test it, right? So Google is giving up to some values. How do you think Google engineers implemented this? Memoization. Okay. Dynamic programming. How do we do dynamic programming here? So Surjit has a very nice idea. Surjit has an idea. He says, hey, Google must have just stored these values. 1 factorial is 1, 2 factorial is 2. Just store it in a hash table and we are done. Probably, right? So 100 factorial, probably they store it. But if that's the case, why didn't they store 200 factorial? One time you compute it and you're done, right? Why don't they just do it? Probably they're not doing the hash table based approach. Probably. I'm not saying, I've not worked at Google search, so I don't know exactly. But probably they're not implementing it, because if they implemented it, they could have gone to 1000 factorial also, no? Probably they're not implementing it like this. Probably because this is part of a dictionary, this is part of a calculator. So probably they have some other implementation here. But it's a good idea, Surjit. It's a nice idea. Probably they're just storing it in a hash table. Yes. Pre-computed answers. Yes. Same story. Somebody saying dynamic programming. How do you do that? Big integer class is used. Yes. But imagine if Google uses big integer class for 100 factorial. It takes a while, man. Even at Google compute power, it takes a while, right? So, so Prithvi, I'm happy. Thank you. You checked it till 170. Good. So somebody has this answer, which is, So Surjit, what you're doing here is factorial n minus 1, factorial n minus 2. Why are we doing this? Why are we multiplying factorial n minus 1 and factorial n minus 2? How do we do that? Probably, how do you think Google is doing it? Okay, imagine you're an engineer at Google. How would you implement this? Think about it. They have values for set number and then just adding the rest of the values. Again, the dictionary value, this is surely one solution. Can you suggest other solution? Probably Google is not doing it. My gut feel is Google is not doing it because they're giving answers only till 170. I mean, there's nothing fancy about 170, right? They could have just gone to 1000 also. PR, KGR. At the end of the day, even with Google's compute, super compute, tensor blocks and things like that, this is compute heavy, man. This is not trivial. Can you think of other suggestions? Can you think of other ideas? Can you think of some other ideas? Think about it. I just told you something at the beginning of the course, at the beginning of this live session. Think. There is a hint that I told you. I want you to apply that hint. Something that I told you very early in this live session. How do you compute n factorial? Fast. Again, I'm not saying this is the exact approach or this is the perfect approach or anything. But remember, factorials, okay, GPU, multi-threading, okay, something more basic. Can we think of something more basic here? Remember, 100 factorial is multiplying 100 with 99, so on. So you have multiplications. Parallel computing, divide it. Okay, we are going in. Again, I'm not saying all these are wrong answers. Infinite series. Yes, how do we get infinite series? Okay, somebody said we'll get infinite series. One thought that I had, if I were to implement it myself, if I were asked this question in interview, one thing I'll say, hey, if this is equals to x, log and exponentiation. Log makes products into additions, right? Look at this. Instead of multiplications, this log itself I'll compute using infinite series. And since I need only 10 most significant digits, I don't need too many significant digits. I only need 10 significant digits. Remember that fact, right? I only need 10 significant digits. So I can do it very fast. I don't require 100 or 1000 significant digits. So even using something like log and exp functions with infinite series, I can do it pretty fast. Actually, please try to implement this in Python and see how fast you can compute this. Okay. I'm sure, again, I'm not saying this is the only solution. I want you to think of other solutions. That's all. Again, some of you have suggested that we'll use parallel programming, we'll use multi-threading. If you tell that in an interview, the interviewer will say, hey, please implement it using multi-threading. How do you speed it up using multi-threading? Or how do you speed it up using multiprocessing? Let's go do it. So in an interview, please make sure that whatever you claim, whatever you say, you better be ready to tackle that question. Follow-up questions based on that, right? So the key takeaway here is math is powerful. Never ignore the basic functions like log and things like that. Okay. So never ignore this. Okay. So again, here our goal here is, again, surely log and exponent are more computationally more expensive than multiplication. But we can't even store a large number. We can't even store this large number in any data structure except big int. Right? We can't store it in any data structure except big int, right? Here the problem is not the multiplication time complexity. The problem is using this big integer, right? By doing this, what I'll do here is I'll only take, when I compute log, right? I'll only compute maybe first few digits. I will not compute all the accuracy stuff. I will not. I'll just completely ignore that. Because the question itself says that I only want, even if you look at Google's answer, right? It only gives you 1 followed by 6 digits. So it's only giving you 7 most significant digits, right? Again, take it as a task. Try to implement this using the log part, right? You can actually do it very, very fast as compared to doing this whole n into n minus 1 for numbers like 100 and 200. Okay, just take it up as a task. Okay, so sounds good. Again, there are other solutions. I'm not saying this is the only solution, but any solution you give, you please be ready to implement it, because the interviewer will ask you, please elaborate more in an actual interview, right? So yeah, so these were some of the concepts that I had at the top of my mind, and these are what I wanted to discuss. I was not sure how much time this would take. We almost spent 90 minutes on this. So I'll take some general Q&As before I wrap up the session itself. Okay, so I have all the questions on the chat window. So I have the chat window and my phone here. I'll try to answer some general questions going forward. Okay, sounds good. So Dhavinit, okay, one second. Okay. So Dhavinit has a nice solution. He's basically using modulo operator. So he's basically saying, I will just ignore. So he's saying I'll multiply n into n minus 1 into n minus 2. That's a nice idea, Dhavinit. Very nice idea. So he's basically multiplying these numbers. This is for the last problem. But whenever the number of digits is too large, he'll just take a modulo 10. Okay. Basically, he's ignoring all the least significant digits. Okay. He might say, hey, whenever I have a number which is more than 20 digits, I will just ignore all these digits now, because they don't actually contribute. They may not contribute as much to the final answer. So he's continuously, whenever the number is becoming too large, he's ignoring some of those digits. That's one strategy, but you have to be careful, slightly careful, to make this actually work in practice. Again, try it out. I have not tried this solution. Try it out. Again, there are some companies who say, hey, let's actually implement it in an online programming tool. Like most companies have built their own tools. They'll give you an online debugger, online programming tool, and say, hey, let's implement it here and see the solution. Okay. Yes, we only want the first 10 digits. Yes, we only want the first 10 digits. Cool. Yeah, some of these questions you can find online also. These are not like all original questions. Most of these are questions that we encountered in our own interviews, that some of our students have encountered in their interviews, some questions that we ask ourselves and things like that, right? So, cool. Sounds good. Okay. Any questions you have? Somebody? Okay. So, yeah. Those of you who don't have any questions, who want to leave, you're most welcome. I'll stay here for a while and try and answer a few general questions. Thank you, folks, for joining. Yes, you can also use a linked list for this. Again, remember, for the last problem, right, what we are using here is a list. A list is internally implemented in Python as a linked list, right? I mean, one of the possible implementations is a linked list. So we can always do that. So Shubham, by mod, I think what he meant was he will discard the last digits. That's what he meant. He didn't mean that he'll take the remainder. I think that was where he got confused. I got the essence of what he wanted, but what he wanted was to discard the last digits. You're right, Shubham, because mod gives the last digits and not the first digits. You're right. So, okay. Shambit says, please give lifetime access to videos. That's a very basic thing that we often mention from day one. There are two problems with it. One, if you cannot learn machine learning in 1 year, and if you're not disciplined about it, you will never complete it. It's just a waste of your time and everyone's time. So we want it to be 1 year, because then you will be serious about completing it and transitioning it. There is no point postponing it forever. That's one. And given our high quality of service and high quality of mentorship, we cannot give it for lifetime, obviously, right? And without mentorship and service, we don't see the point in the course. Okay, I hope that answers your question, Shambit. Okay, so next is, so Dvanit has any updates on PGD AI/ML? Again, I think we have got a lot of applications. Most of these applications are being processed by University of Hyderabad now, because they verify all of your academic certificates and then they shortlist candidates. We are expecting the results to be sometime mid to late December, most likely. And the course itself will start in early Jan. You'll get most of your results by maybe second or third week of December, the admission letters, and then some of you may be in wait list. Again, the admission decision is completely taken by University of Hyderabad based on your academic and credentials and work experience. Okay, cool. One second. So this is a good question. Prithvi says TF is implemented in C++. So underneath it again uses C. Yes, Prithvi, the reason Google implemented TensorFlow in C++ is because C++ is super fast. The reason they did not implement it in C is because C++ has classes, right? C++ they can use all the beautiful design concepts of object-oriented programming and design to do it well. So the core of TensorFlow itself is all in C++. Python is an interface on top of it, right? Okay, this is a very good question. So Ajay says, can you explain the differences between DS, MLE and MLS in detail? Okay, so I'll spend some time. It's a very nice question. I'm glad somebody asked this. So a data scientist, okay, so let me put it this way. Okay, so since we anyway are on this page, let me answer this question in detail because I keep getting this question very often. Okay, so as a data scientist, your skill sets are, you know, coding, you know, SQL, you know, basic data structures, inbuilt data structures, you know, machine learning algorithms, you know, of course, some basic deep learning. You also know a lot of data analysis and things like that. But you're not expected to have a lot of depth in any of these. Of course, applied aspects are very, very important for a data scientist. But let's compare data scientist with a machine learning engineer and a machine learning scientist. As compared to a machine learning engineer will require everything that a data scientist knows. But in addition to it, this is something where candidates are expected to be very good at software engineering, software development. So that's why machine learning engineer is something that people with software development engineering experience typically go into, right? So again, there are some software development engineers who also go into data as data scientists. So the core here is this. A data scientist is expected to know, the applied aspects, the basics of data, the concepts behind probability, statistics, data analysis, plotting, machine learning, deep learning, coding, SQL, all of that stuff. But the depth of expectation is significantly lower, right? The expectation from them in terms of mathematical depth or in terms of coding depth and coding ability is significantly lower. For a machine learning engineer, everything that is expected from a data scientist will be expected, but they'll be expected to be much stronger in programming, data structures, algorithms, object-oriented programming, etc. based on the experience. A machine learning scientist is somebody who needs to have all the skills of a data scientist, but need to know the math inside out. Most machine learning engineers may not be very deep in math, but they're very good. So if you look at skill sets, right? So you have a data scientist as the base. So a data scientist plus software development engineering skills gives you machine learning engineer. A data scientist plus math skills. Okay, let me just draw it here. A data scientist plus somebody who is strong in math gives you a machine learning scientist. Basically, this is what it is. All of them need to know. If you go for a machine learning scientist interview, the math is going to be deep and dense, right? For senior scientists, you're expected to, again, for senior roles, okay, I'll come to senior roles, okay. For entry-level roles, a data scientist should know all these things that I just mentioned. Applied aspects, how do you solve a problem end-to-end, data analysis, machine learning, deep learning, coding, SQL, basic data structures, all of that stuff. So somebody who has all the skills of a data scientist, but also knows software development, more data structures algorithms, more object-oriented programming, probably experience with object-oriented programming, maybe 3 years, 5 years, 10 years experience as software engineers, they can become machine learning engineers. So somebody who is very strong, who has all the knowledge of data scientists, but very strong in math, they become machine learning scientists. Basically, this is what it is. Even in terms of compensations, the compensation of a data scientist will be less than the compensation of a machine learning engineer. So DS compensation is typically, most often, less than a machine learning engineer, which is less than a machine learning scientist. I'm not saying, again, these titles are used left and right. Okay, these are titles. I'm talking about generally how these titles are used. You might have some companies where data scientists are making more than machine learning scientists because of the role, right? But in general, this is what it is. A data scientist who is experienced, they are expected to perform more complex data analysis, more innovative data analysis. They're expected to be able to solve a problem more end-to-end. Think about alternate solutions. Somebody who is a senior machine learning scientist is like, he knows the math, they know the literal cutting edge of stuff, and they also can deploy things. They can also do all of the other stuff. A senior software development engineer knows more software engineering stuff like low-level design, high-level design, right? Designing like a system design and things like that, right? So again, our course fundamentally prepares people for data scientist roles. There are also some preparation for SDE roles through our assignments and things. There is also preparation for machine learning scientist. So our course participants have landed in all three types of roles based on what they are good at. If they're good at all the basics, they typically end up as data scientist roles. If they're, in addition to data science skills, if they're very good in software engineering, they end up in machine learning engineer roles. In addition to data science skills, if they're not very good in software development but very strong in math, they join as machine learning scientists or applied scientist roles, right? This is the typical nature. In terms of work, there is a lot of overlap. Again, depending on the project, depending on things, there is a lot of variability. Like as a machine learning or an applied scientist, I have done the work of a machine learning engineer. I have done the work of a data scientist. I have done all of these in my career. Okay. So I've been through work itself. There will be a lot of overlap. Okay, cool. I hope that answers the questions. Okay, so let me go up again. Okay. So that was a good question. So let's take more questions now. 1 second. Okay, let me just scroll down. Okay. So is the math covered in applied AI course sufficient for machine learning scientist? Yes. So we have had some of our students who landed as machine learning or applied scientist at some of these companies like Microsoft, Amazon, etc., following through our course itself. Please give a perfect link to download Python. Come on, you can just Google search that, right? You can install Python using Anaconda or any tool of your choice. It's fairly straightforward. Again, it's just a Google search away. So this is ML aficionado. I think that's an alias. I'm from ETL background and I do not have software programming. So data scientist will suit me. Yes, that's true. If you have prior experience in ETL or SQL and things like that, data scientist is the most appropriate role for you. But since you have prior ETL experience, the SQL queries that will be asked of you will be slightly on the advanced side. Okay. So Vijay says, please conduct live sessions on DL interview questions. We have conducted them in the past for the course enrolled students. So we'll try to conduct them in the future also. So if someone has experience as a web developer for 3 years and having good math skills and machine learning, can he approach MSc right? Yes. So you might, so depending on how well you know software development that you have learned through web development, you could try both data scientist as well as machine learning engineer roles. Okay. Can you speak about roles for people who are good in deep learning? Again, whether nowadays every company for all these 3 roles, they ask deep learning, right? So again, there are some roles like computer vision engineer, deep learning engineer, etc. Most of those roles will ask you everything that is there in this, right? So a computer vision engineer probably has 1 or 2 extra rounds of computer vision. Of course, you have to be very comfortable with convolutional neural networks and variations of CNNs for such a role. An NLP engineer probably has to be better with transformers in deep learning. So they might have a dedicated round for NLP or 1 or 2 rounds dedicated for NLP, right? Yes, NumPy is written in C, C++. That's true. So how much important is data structures and algorithms for data science and machine learning roles? Again, as I mentioned, if you're looking for a machine learning engineer role, you're expected to know more data structures and algorithms, most likely because you have software development engineer experience or you come from a computer science background. This is especially true for top product-based companies only. For data scientist and machine learning scientist roles and for people who come from non-CS backgrounds, basic data structures that are inbuilt in Python, your list, your tuple, your set, your hash table, those are pretty good. Okay, if you can use those 4 or 5 basic data structures in Python, you can tackle most problems. So which one is tough, getting an ML job or a data science job? Again, there is a lot of overlap between these 2 roles, but in general, getting a data scientist role is easier than a machine learning engineer or a machine learning scientist role in general. Can I solve challenges in Kaggle after I finish the course? A lot of people, as part of their self-case studies, participate in Kaggle. We have people who come in top 4%, top 5%, top 10% in Kaggle competitions. So that's a very common thing that people do. Okay. So has the machine learning course covered all the syllabus for data science? Again, Shwastik, how do you define the syllabus for a data science role? That's very tricky. So what we do here is we cover all the concepts that you need to crack data science roles. Bottom line is that, or at least most of the roles. Again, our content is constantly evolving. We constantly update it. We constantly change it. We add live sessions like this to keep it market ready always. Okay. How much SQL should you know? We have done a live session on that. We have discussed about what sorts of SQL questions you can expect. Just go to our YouTube channel. You'll find questions like this. We have done exactly just like programming for ML and AI. I think there is a session called SQL round that you can expect at product-based companies, services companies, etc. There is a whole dedicated session on that. Please check it out. Okay, cool. 1 second. So CG says, I don't have experience in IT. I have experience in marketing and sales, BTech in ECE. CG, in your case, there are some marketing analytics roles. There are also roles where machine learning and AI are used, or data science is used in digital marketing and marketing analytics types of roles. Those are types of roles that you could target for. Again, but you have to learn all of the mathematics, programming, and the internals if you want to land in those roles. So are mechanical engineers not eligible to pursue course at Applied AI? No, nothing like that. But so whenever you reach out to us over the phone, we go through your resume. We sometimes ask you to share your resume in case we are doubtful. We evaluate your resume. And if we are not confident that we can place you at the end of the course, we tell you very upfront that probably we will not be able to do it. Okay. So, but most often, if you're a mechanical engineer and if you can follow through most of the course videos, and you can pick up the programming that we have in the free videos, and if you can complete all of that, I think you can complete the rest of the course. Is math covered in Applied AI course very difficult? Again, Manoj, what we try to do in our course is we try to simplify most of the math. I do not say it is trivial, but we try to teach you from very, very foundational stuff. Again, you can check out, we have almost 40 hours of free videos and live sessions on our YouTube channel, on our website. Please check them out. See if you find it very difficult. Again, a lot of math concepts we have added in the free videos because a lot of people panic about math. Check out our approach to the problems. If you like it, if you can understand it, I think you should be able to follow the course. So this is by Somdev. How will the new PGD program be different from existing Applied AI course? Again, the PGD course is a very academic course. So while there will be a lot of applied concepts because we are the co-creators of the course, it will also have a lot of academic bent because there will be co-instructors from University of Hyderabad, from the industry, etc. And it will have a very clear semester structure. So you'll have mid-semester exams, semester exams. So it will follow that proper academic structure. In terms of quality of teaching, it will be very similar, and we are trying to make it better than what we have at Applied AI course through partnerships with other faculty members. But the quality, we'll try to keep it at the same level and preferably better, right? So, but remember that it's an academic program. You have to spend 1 year, attend all the exams, clear all the exams. All the exams will be conducted by UIH. So it's more of an academic credential. And again, that academic credential is recognized all over the world because it's given by one of the top universities, and that PGD itself is recognized by University Grants Commission, which means if you're, again, some students also asked us this, that we are applying for Canadian permanent residency, so-and-so, is this recognized? Yes, we verified it from University of Hyderabad that this is a proper university degree program, right? So those are some of the advantages you get from that. Cool. Okay. So there is a flood of questions, folks. Please understand that it is almost impossible for me to answer all the questions. I'll do my best. Again, it's simply impossible for me to do it. So anything that I cannot cover, that I cannot answer in this session, feel free to reach out to us via email, and we'll try to answer anything that we could not do it here. Okay. So Vijay says, how do I get a job after completing 15 assignments? Again, we start our job guarantee program after you complete 30 assignments, but we have had students who finish all the videos. Like you might have seen some of the success stories also, where people do a few assignments and people work on a side project of their own. They put in their resume, apply it on all job portals, and sometimes they get calls and they crack. But for all the recruiters that work with us, what we do is we very clearly tell them that here is the review from the 30 assignments. Here are the 2 mock interviews that we conducted. Here is the feedback, because we also are answerable to the recruiting partners we have. We want to be as transparent to them as possible. Okay. So please talk about the job scenario. Thankfully, the job scenario now is not as bad as it was in April, May, June. It is improving. But to be honest with you, it's not back at the same level because companies haven't revamped the whole hiring, because companies are also still skeptical about where things will be, where economies will be, both India, US, Europe, etc. So the recruiting is not back to the same stage as it was pre-COVID, but it is not as bad as April, May, June, right? So Monster says, okay, that I think this is a Elias. Since the course is long, I'm getting little desperate for a job. I'm a 2020 pass out. I'm planning to learn Tableau. Should I put my time in it? Monster, remember, you can always do it. Learn Tableau, parallelly learn things from Applied AI course. Tableau is just a tool. Remember that. You still need data analysis skills. You should know what a PDF is, what a CDF is, how to make conclusions from PDF, CDFs, all sorts of plots. Tableau is just a tool. Whatever you can do in Tableau, you can do it in Python also. So if you're desperate for a job because you're having some gap right now, feel free to learn other skills. We encourage that. Why not? We don't want students to have career gaps ideally, right? So if you're still going through the course, feel free to do other stuff, learn other things like Tableau, apply everywhere. But please don't give up learning on the course. While it might take some time, if you're consistent with it, you can comfortably finish it. Okay. Do I need to go through some books based on Python while going through the ML course? Not required, Hariharan. We have tons of Python content and Python practice as part of assignments, right? You will get ample practice for programming throughout our course. Again, we have done tons of live sessions with code walkthroughs in Python, etc. So we don't recommend anything. If you need anything, if you're stuck at anywhere, do reach out to us. You don't need another textbook to follow parallelly. Okay. Sounds good. Okay. So very good. So Satyaki says, please tell how people with 1 to 2 years career break can get into industry through this course. Satyaki, I think I've answered this question earlier also. I believe you asked this question. So what we're doing with a lot of companies now is, this is something that companies also like. We are informing companies that instead of taking resumes, because earlier we used to just give a bunch of shortlisted resumes based on how well they've completed the course, what skills the company is asking for. And we would give them the feedback on the 30 assignments, the 2 mock interviews and things like that. Now what we're doing more and more is we're asking companies to conduct a test. Think of it like a screening test. Or we're asking companies to give a screening task. The reason we are doing this is because of career gaps, whatever reason, right? And because some people could come from other backgrounds. This is basically a purely meritocratic system now, right? Companies come, and companies also like this because we are like, okay, please set the question paper, or we'll work with you, set the question paper based on what you want. Let's conduct a test. Let students take the test. Whoever performs well, we should interview, irrespective of their career break. This is one strategy that we are following very closely to get some of the students with career breaks a chance. Parallelly, what you should do here is when you have a career break, you should be able to justify their career break. Very importantly, some of our students, not all, some of our students with career breaks took up internship options and converted that into full-time roles. Okay, that's a very, very useful strategy. You will see some of our success stories of candidates also with career breaks. Some of them had very strong case studies, very strong end-to-end case studies through which they got through. Others went in as interns and then converted into full-time roles. These are 3-4 strategies that we employ to help people with career gaps. Okay, so Jill says, are there future courses like system design and low-level design? Jill, it is still in a design phase. I do not want to comment at it now, but surely we'll have something going in the next year. Okay, we are working on it. We have lot of mentors and advisors and co-instructors that we are gathering together for a software design course where we will cover LLD and HLD, but it is still at a very initial stage. I don't want to give an ETA right now. As and when it is ready, we'll inform you. So sounds good. So Satyam has a question. Is it difficult for BSc in mathematics to get a data science role? So Satyam, my recommendation for you is this. Typically BS in maths folks or statistics folks, they have reasonably good math skills, but they don't have application skills and they may not have programming skills. So if you're a BS in mathematics, I would recommend, and again, BS in India is a 3-year program. It's not a 4-year program. You can get into data science roles. You mostly will join as a data analyst in roles, especially if you're good at programming. and especially if you're comfortable with applying some of the math that you learn to real world problems. But we also recommend that you consider pursuing an MCA, right, a Master of Computing Applications, because then you can take your math knowledge, you can take some of the learnings from an MCA like program, right, which will teach you all the programming stuff. You can combine both of them and you have much better chances then. Okay, that's what we recommend. So Vijay is asking date for PG shortlist. Again, the university told us that it will be sometime in the second, maybe third week of December, right? So worst case, the last week of December. Sounds good, folks. 1 second. So this is Jello. Jello asks, I don't know, I'm not able to pronounce his first name. If I'm not interested in job, but I'm interested in learning, would the course fee be the same? Again, Jello, we provide service mentorship irrespective of whether you are looking for a job or not. We have some candidates who are like, I'm not looking for a job, but this is what I'm looking for. So the effort from our side, the mentorship guidance, all of it is the same, and hence the course fee would remain the same. So Shubham says, I'm not able to perform well in AAC monthly tests. What should I do? Good question, Shubham. So every question that is asked of you, ask yourself, what are you doing a mistake in? Okay, so we are conducting, by the way, for those of you who don't know, we conduct these monthly tests at Applied AA course so that students revise and students are also prepared better for, I think we had a test today or yesterday. I think today, I believe, if I'm not wrong, right? So we conducted these tests. We are conducting these tests because a lot of companies are creating these screening tests with us. Okay, these are like practice tests for them. So whenever you're not performing well, ask yourself this question. Why couldn't I answer this question? 90% of the cases when we analyzed this data, it is because the student hasn't revised the concept. He went through the concept, he did the assignment, but he has forgotten it. So most importantly, please revise. I can't emphasize this enough. Revise the concepts, revise the mathematical foundations, because the questions that we ask are actually what are typically asked. Like we take actual interview questions, modify them slightly and put it in actually like an online exam format. That's what we are doing with all these monthly tests, right? So please try to do that. Most often it is revision. 99% of the times it is revision. Again, please reach out to us if you need any help from our front. We will surely help you, right? Yeah, we had an exam today. I remember that. Okay. So again, these tests are conducted for people. Again, all these tests are announced in our classroom, especially for candidates who solve a certain number of assignments. Otherwise, you're not prepared for the tests also. Okay. Sounds good. Sounds good. Okay. No, is it possible to get the test questions again? No. So we are not doing that. So please go take the tests. Okay. That will help you. Sounds good, folks. That's all. I think we answered most of the questions or most of the types of questions that students had. And thank you for joining. It's anyway close to 9 p.m. I know some of you have to get back to work tomorrow. Yeah. So, and some of you have to go back to colleges also starting tomorrow. Again, most importantly, please stay safe. In most places in the world, there is a second wave of COVID infections. So I recommend all of you stay safe with your family. I know there are some big celebrations like Christmas, New Year, Pongal or Sankranti in south of India. So please stay safe through this. I cannot emphasize this. And yeah, all the very best. Again, any question that I could not answer that you think is too important, again, please understand that in a public interview, in a public session like this, it's hard for me to answer all the questions. Please email us. One of our team members will surely respond to you. Thank you, folks. Thank you very much. Bye-bye.